In the vast, dark ocean of the cosmos, something extraordinary happened. Matter began to think. Atoms forged in stars came together to form neurons, and through them, awareness itself. You, sitting here, are a fragment of the universe that has become self-aware. But is consciousness merely a biological accident, or is it woven into the very structure of reality itself? Before we begin, a quick note. This documentary is not fiction, nor is it fully generated by artificial intelligence. Every concept and event you'll hear in this narration is based on verified, peer-reviewed science, carefully examined and interpreted for clarity. Some of the visuals you'll see are artistically generated to help illustrate complex ideas. Think of them not as imagination, but as visualization, a bridge between what science understands and what we are still discovering. And if you find value in these explorations, thoughtful science told with care, a quick subscribe helps us continue creating more journeys like this one. Now, let's journey inward to the deepest mystery of all, the link between the human mind and the cosmos that created it. This could change everything we know. Inside your skull, at this very moment, something impossible is happening. 86 billion neurons, each no larger than a speck of dust, are firing in precise patterns, creating the universe of your experience. The words you're reading, the thoughts forming in response, the sense of you that experiences it all, none of this should exist, yet here it is. Neuroscience has mapped the brain with extraordinary precision. We know that visual information travels from your eyes through the optic nerve to the visual cortex. We can trace the pathways of memory formation in the hippocampus, watch emotions flare in the amygdala, and observe decision-making unfold in the prefrontal cortex. We've identified the neural correlates of consciousness, the specific brain patterns that accompany awareness. But here's what remains deeply mysterious. Nowhere in this intricate biological machinery can we find experience itself. We can see the neurons firing when you taste chocolate, but we cannot locate the sweetness. We observe the electrical activity when you feel joy, but the feeling itself, that warm, ineffable sensation, exists nowhere in the physical brain we can measure. This is what philosopher David Chalmers famously called the hard problem of consciousness. Science excels at explaining the easy problems, the cognitive functions, information processing, and behavioral responses of the brain. But explaining why there's an inner subjective world at all, why there's something it's like to be you, remains the deepest puzzle in all of science. Consider the paradox. Your brain is made of the same basic materials as rocks, water, and stars, protons, neutrons, and electrons arranged in different patterns. Yet somehow, this arrangement of ordinary matter has given rise to something that seems entirely extraordinary, your conscious awareness. It's as if the universe has evolved a way to experience itself, to know that it exists. Traditional materialist approaches suggest that consciousness emerges from complex interactions between neurons, that awareness is simply what happens when information processing reaches a certain threshold of complexity. But this explanation, while scientifically respectable, leaves many questions unanswered. If consciousness is just complex computation, why do we have subjective experiences at all? Why isn't the brain simply a biological computer that processes information without any inner life? Some scientists and philosophers have begun exploring a radically different possibility. What if consciousness isn't something that emerges from matter, but something that's woven into the very fabric of reality itself? What if awareness, rather than being produced by the brain, is instead a fundamental feature of the universe, as basic as mass, charge, or spin? This idea, known as panpsychism, suggests that all matter possesses some form of consciousness, however primitive. Your neurons don't create awareness from nothing. They organize and amplify the consciousness that was already there, like a radio tuning into a cosmic frequency that permeates all of space and time. If this sounds far-fetched, consider that it solves the hard problem entirely. Instead of trying to explain how unconscious matter becomes conscious, we start with consciousness as a given, a property as fundamental as the forces of physics themselves. The brain becomes not the creator of consciousness, but its most sophisticated expression in the known universe. But this raises an even more profound question. If consciousness is woven into the cosmos, what does that tell us about the nature of reality itself? Are we isolated islands of awareness in an unconscious universe? Or are we connected to something far greater than ourselves? The mystery begins in the brain, but as we'll discover, it may end in the stars themselves. Every atom in your body tells a story that spans billions of years and trillions of miles. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was forged in the nuclear furnaces of ancient stars that lived, died, and scattered their essence across the cosmos long before Earth existed. Carl Sagan captured this profound truth with elegant simplicity. We are made of star stuff. But the implications run deeper than poetry. The very atoms firing in your neurons at this moment, creating your thoughts, your memories, your sense of self, are the same materials that once burned in stellar cores and now form the scaffolding of galaxies. When a massive star reaches the end of its life, it doesn't simply fade away. In a supernova explosion that outshines entire galaxies, it hurls the heavy elements it spent millions of years creating into the surrounding space. These stellar deaths become cosmic births, seeding the universe with the building blocks of chemistry, biology, and consciousness. The carbon atoms in your DNA were forged in stars that died before our solar system was born. The phosphorus that carries energy through your cells was created in the final moments of stellar collapse. Even the water that makes up 60% of your body, hydrogen married to oxygen, carries the signature of cosmic evolution stretching back to the universe's first 3 minutes. The cosmic web, the largest known structure in the universe, consists of billions of galaxies connected by filaments of dark matter and gas, separated by vast empty voids. These cosmic highways stretch across hundreds of millions of light-years, channeling matter and energy between distant galactic clusters in patterns that look remarkably familiar. Under a microscope, the human brain reveals a similar architecture. Billions of neurons connected by axons and dendrites, with information flowing along pathways separated by empty space. The resemblance isn't just superficial. Mathematical analysis reveals that both systems share nearly identical statistical properties in how they organize information and distribute connections. Consider the numbers. Your brain contains roughly 86 billion neurons, while the observable universe contains roughly 100 billion galaxies. Each neuron connects to thousands of others, creating a network of extraordinary complexity. Each galaxy gravitationally influences its neighbors, creating structure on the largest scales imaginable. Both systems emerged from initial conditions that were almost perfectly uniform: the smooth early universe and the seemingly homogeneous neural tissue of the developing brain. This parallel suggests something profound about the way complex systems organize themselves. Whether we're looking at networks of neurons or networks of galaxies, the same underlying principles seem to govern how structure emerges from chaos, how information flows through vast networks, and how simple components give rise to behaviors that transcend their individual capabilities. In your brain, the flow of electrical impulses along neural pathways creates the phenomenon of thought. In the cosmic web, the flow of matter and energy along galactic filaments may create something we don't yet understand, a form of information processing on scales that dwarf human comprehension. Some scientists have begun to wonder whether this similarity is more than a coincidence. If consciousness emerges from the complex interactions of neural networks, could something analogous emerge from the complex interactions of galactic networks? Are we witnessing the same fundamental principles of organization playing out on scales separated by 40 orders of magnitude? The atoms in your neurons carry not just the history of stellar evolution, but perhaps something even more remarkable. They may carry the patterns and processes that govern the universe itself. When you think, you're not just processing information. You're participating in the same kinds of network dynamics that shape reality on the largest scales imaginable. Your consciousness isn't separate from the cosmos. It's the cosmos becoming aware of itself through the temporary arrangement of star-forged atoms we call a human brain. The universe spent 13.8 billion years evolving the capacity to think, and in this moment, through your awareness, it's finally able to contemplate its own existence. Perhaps the cosmos didn't just give birth to consciousness. Perhaps it gave birth to itself. Deep within each of your neurons, in structures smaller than viruses, something extraordinary may be happening. At scales where the strange laws of quantum mechanics begin to dominate, the classical physics that governs our everyday world gives way to a realm of possibilities that seems almost magical, and it may be the key to understanding consciousness itself. For decades, neuroscientists assumed that the brain operated purely as a classical system. Neurons fire or they don't, like switches in a computer. Electrical signals travel along pathways, chemicals cross synapses, and complex behaviors emerge from the interactions of billions of these simple on-off switches. It's an elegant model that explains much of what we observe about brain function. But this classical view faces a problem. It cannot explain why there's subjective experience at all. If the brain is just a biological computer processing information, why should there be an inner world of qualia, the redness of red, the pain of pain, the joy of joy? Why isn't the brain simply an unconscious information processing system, like a very sophisticated smartphone? This puzzle has led some scientists to look deeper into the quantum realm that underlies all classical physics. At the scale of atoms and molecules, reality behaves in ways that challenge our everyday intuitions. Particles can exist in multiple states simultaneously, influence each other instantaneously across vast distances, and tunnel through barriers that should be impossible to cross. At first glance, the warm, wet environment of the brain seems like the last place quantum effects could survive. Quantum states are notoriously fragile, easily destroyed by thermal noise and environmental interference. Most scientists assumed that quantum coherence, the delicate state that allows particles to exist in superposition, would collapse instantly in the brain's chaotic cellular environment. But recent discoveries in quantum biology have shattered this assumption. From photosynthesis in plants to navigation in birds, life has evolved sophisticated mechanisms to harness and protect quantum effects for biological advantage. Chlorophyll molecules maintain quantum coherence for surprisingly long periods, allowing plants to explore multiple energy pathways simultaneously and find the most efficient route for capturing sunlight. Certain birds may use quantum entanglement in their visual systems to see magnetic fields and navigate across continents. If nature has learned to exploit quantum mechanics in these simpler systems, could the brain, the most complex biological structure we know, have evolved even more sophisticated quantum mechanisms? This possibility led physicist Roger Penrose and anesthesiologist Stuart Hameroff to propose one of the most controversial theories in neuroscience: orchestrated objective reduction, or OR. According to their theory, consciousness arises from quantum computations occurring within microtubules, tiny protein structures that form the skeleton of neurons. Microtubules are fascinating structures in their own right. Made of tubulin proteins arranged in precise geometric patterns, they serve as both structural supports and information highways within cells. But Penrose and Hameroff suggest they may be something more: biological quantum computers, capable of maintaining coherent quantum states and performing computations that are impossible for classical systems. In their model, tubulin proteins within microtubules can exist in quantum superposition, exploring multiple computational pathways simultaneously. These quantum states orchestrate across the microtubule network, creating a vast quantum computer distributed throughout the neuron. When this quantum computation reaches a critical threshold, it triggers what Penrose calls objective reduction, the collapse of the quantum superposition into a specific classical state, accompanied by a moment of conscious experience. The theory is audacious and controversial. Many neuroscientists argue that the brain is too warm and noisy to maintain the delicate quantum states required for OR. Critics point out that quantum decoherence should occur within picoseconds in neural tissue, far too quickly to influence the much slower processes of neuronal firing and consciousness. But recent experiments have begun to reveal quantum effects in biological systems that were previously thought impossible. Microtubules have been shown to exhibit quantum vibrations at warm temperatures. Anesthetics, which eliminate consciousness, appear to disrupt quantum processes in microtubules at concentrations that correlate precisely with their anesthetic potency. Most intriguingly, weak electromagnetic fields that shouldn't affect classical neural processes can influence consciousness and cognition, suggesting that quantum mechanisms may indeed play a role in brain function. Whether or not OR proves correct in its specific details, it points toward a profound possibility. Consciousness may not emerge from the classical interactions of neurons alone, but from quantum processes that connect the brain to the fundamental behavior of the universe itself. If consciousness involves quantum mechanics, then your awareness is not just a product of biological evolution, it's a manifestation of the same quantum field that governs the behavior of particles throughout the cosmos. Your thoughts may literally exist in the same quantum realm that connects all matter and energy across space and time. This raises a tantalizing question. If consciousness emerges from quantum processes, and quantum mechanics governs all of reality, could awareness itself be a quantum phenomenon that extends far beyond the boundaries of individual brains? The answer may force us to reconsider not just the nature of consciousness, but the nature of reality itself. In a laboratory at the turn of the 20th century, physicists made a discovery that would shatter our understanding of reality. When they fired electrons through two parallel slits, something impossible happened. Each individual electron seemed to pass through both slits simultaneously, creating an interference pattern that could only result from the electron interfering with itself. But here's where the story becomes truly mysterious. the moment scientists tried to observe which slit the electron actually passed through. By placing a detector at one of the slits, the interference pattern vanished. The electron began behaving like a classical particle, choosing one slit or the other, but never both. This is the observer effect, and it suggests something profound. The act of observation fundamentally changes the nature of reality at the quantum level. Without observation, quantum particles exist in superposition, occupying multiple states simultaneously. With observation, this ghostly superposition collapses into definite classical reality. But what constitutes an observer? Is it the conscious scientist watching the experiment? Is the electronic detector recording the data, or something else entirely? For nearly a century, physicists have debated whether consciousness plays a special role in quantum mechanics. The orthodox interpretation suggests that any interaction with a measuring device causes wave function collapse, regardless of whether a conscious being is present. But a minority of physicists, including Nobel laureate Eugene Wigner, have proposed that consciousness itself may be the key factor that determines when quantum superposition collapses into classical reality. The implications are staggering. If consciousness plays a role in determining what becomes real, then observers aren't passive witnesses to an independently existing universe. They're active participants in creating reality itself. Consider the delayed choice quantum eraser experiment, one of the most mind-bending demonstrations in all of physics. In this setup, scientists can choose whether to observe which path information about a photon, even after the photon has already hit a detector screen. Remarkably, this future choice retroactively determines whether the photon exhibited wave-like or particle-like behavior in the past. The experiment suggests that the decision to observe, made by conscious experimenters, can influence events that have already occurred. The future seems to reach back and determine the past, mediated by the choices of conscious observers. Even more puzzling are experiments involving quantum entanglement, where particles become correlated in such a way that measuring one instantly affects the other, regardless of the distance separating them. Einstein famously called this spooky action at a distance, but experiments have confirmed that entangled particles do indeed influence each other instantaneously across any distance. Recent experiments have pushed this further, creating entanglement between the past and future. Photons that never existed at the same time can become entangled through careful manipulation of their quantum states, suggesting that quantum correlations transcend not just space, but time itself. If consciousness is required to collapse quantum wave functions, then every moment of awareness may be an act of cosmic creation. When you observe the world around you, when you choose to pay attention to this word, this thought, this sensation, you may be actively participating in the creation of reality. This possibility becomes even more intriguing when we consider that the human brain itself operates through quantum mechanical processes. If consciousness emerges from quantum computations in microtubules, as suggested by theories like Orch-OR, then every thought may involve the collapse of quantum superpositions within your neurons. Your brain might be a quantum measurement device of extraordinary sophistication, constantly collapsing quantum possibilities into the classical reality of conscious experience. Each moment of awareness could represent billions of quantum wave functions collapsing simultaneously, transforming the ghostly potential of quantum superposition into the definite reality of conscious thought. But this raises profound questions about the nature of reality when no one is observing it. If consciousness plays a role in collapsing quantum states, what happens to the universe when no conscious beings are present to observe it? Did the universe exist in some ghostly superposition of all possible states before the first conscious observers evolved? Some interpretations of quantum mechanics suggest exactly this. The universe may have existed in quantum superposition for billions of years, with all possible histories playing out simultaneously, until consciousness evolved and began collapsing these possibilities into the single classical reality we experience today. This would mean that consciousness isn't just a product of cosmic evolution, it's the force that transforms cosmic possibility into cosmic reality. The universe may have spent 13.8 billion years evolving observers not just to understand it, but to make it real. The observer effect reveals a deep mystery at the heart of existence. The boundary between mind and reality may be far more fluid than we ever imagined. Your consciousness doesn't just perceive the universe, it may be actively creating it, one observation at a time. And if that's true, then every conscious being in the universe is participating in the ongoing creation of reality itself, connected through the quantum field that underlies all existence. The question becomes, who or what is doing the ultimate observing? Beneath every law of physics, every biological process, every conscious thought, lies something that we're only beginning to understand: information. Not the abstract concept of data storage, but something far more fundamental. A hidden thread that may weave together matter, energy, space, time, and consciousness into a single cosmic tapestry. The story begins with black holes, those gravitational monsters that devour everything in their path. For decades, physicists assumed that black holes destroyed information permanently. Anything that fell past the event horizon, every bit of data that described its properties, seemed lost forever, crushed into the singularity at the black hole's heart. But Stephen Hawking discovered something remarkable. Black holes aren't perfectly black. They emit radiation, slowly evaporating over cosmic timescales. This presented a paradox that shook the foundations of physics. If black holes evaporate completely, what happens to all the information they swallowed? The fundamental laws of quantum mechanics insist that information cannot be destroyed, yet black holes seem to violate this principle. The resolution to this paradox revolutionized our understanding of reality. Physicists realized that black holes don't destroy information, they encode it on their surface, in the quantum fluctuations of their event horizons. Every bit of information that falls into a black hole becomes holographically encoded on its two-dimensional surface, even though the black hole itself exists in three-dimensional space. This discovery led to a profound insight. The amount of information that can be stored in any region of space is proportional not to its volume, but to the area of its boundary. The three-dimensional reality we experience may actually be a holographic projection of information encoded on a two-dimensional cosmic surface. But the information paradigm extends far beyond black holes. DNA, the blueprint of life, is pure information, a four-letter code that stores the instructions for building and maintaining every living thing on Earth. Your genome contains roughly 3.2 billion base pairs, equivalent to about 750 megabytes of data. Yet this modest amount of information is sufficient to encode not just your physical form, but many aspects of your behavior, personality, and even predisposition to certain thoughts and emotions. The human brain itself is fundamentally an information processing system. Your neurons encode memories as patterns of synaptic connections, with each memory distributed across networks containing millions or billions of synapses. The information capacity of the human brain has been estimated at anywhere from 1 terabyte to 2.5 petabytes, roughly equivalent to the entire internet's worth of data. But consciousness may represent something even more remarkable. information that has become self-referential. Unlike a computer, which processes information without any subjective experience of doing so, conscious beings create an inner model of themselves processing information. You don't just think, you're aware that you're thinking. You don't just process sensory data, you experience the redness of red, the warmth of sunlight, the satisfaction of understanding. This suggests that consciousness might be information that has folded back on itself, creating a strange loop where information processes become aware of their own processing. Your sense of self may be the universe's information structure contemplating its own existence through the temporary pattern we call a human brain. Physicist John Wheeler captured this idea in his famous phrase, "it from bit," the notion that physical reality emerges from more fundamental informational processes. In Wheeler's vision, matter, energy, space, and time are not the primary constituents of reality, but rather derived properties of underlying information relationships. Modern physics increasingly supports this view. Quantum mechanics describes reality in terms of information and probability rather than definite material properties. Before measurement, particles don't have specific positions or momenta. They exist as probability distributions, pure information about what might be observed. The act of measurement doesn't reveal pre-existing properties. It actualizes possibilities encoded in the quantum information field. Even more remarkably, recent discoveries in quantum information theory suggest that space and time themselves may emerge from more fundamental information relationships. Entanglement, the quantum correlation between particles, appears to create the fabric of space-time itself. Where there is strong entanglement, space is smooth. Where entanglement breaks down, space may become discontinuous. This leads to a breathtaking possibility. The entire universe may be a vast information processing system, with consciousness representing its most sophisticated self-referential subroutine. Every physical interaction may be a form of computation, every quantum measurement a moment of information actualization, every conscious thought a recursive loop in the cosmic information structure. If reality is fundamentally informational, then consciousness isn't separate from the physical world. It's the universe's way of processing information about itself. Your awareness may be a local manifestation of the same informational processes that govern quantum mechanics, organize galactic clusters, and determine the evolution of the cosmos itself. This raises the ultimate question. If the universe is an information processing system that has evolved the capacity for self-awareness through conscious beings, what is the purpose of this cosmic computation? What problem is the universe trying to solve? The answer may lie in the most profound mystery of all: why anything exists at all, rather than nothing. Perhaps consciousness represents the universe's attempt to understand itself, to process the information of its own existence, to answer the deepest question, not just how reality works, but why there is something rather than nothing. And if that's true, then every conscious thought, every moment of awareness, every act of understanding is part of the universe's quest to comprehend its own existence. We are not just observers of cosmic information, we are the cosmos reading itself. Step back from Earth, beyond our solar system, beyond our galaxy, to the edge of the observable universe. From this cosmic vantage point, something extraordinary becomes apparent. The universe appears to be precisely calibrated for the existence of consciousness itself. The constants that govern physics, the strength of gravity, the electromagnetic force, the mass of protons and electrons, all seem fine-tuned to within impossibly narrow margins. Change any one of these values by even a tiny fraction, and stars cannot form. Chemistry becomes impossible, and consciousness never emerges. Consider gravity. If it were slightly stronger, stars would burn out too quickly for life to evolve. If it were slightly weaker, stars would never ignite in the first place. The universe would remain a cold, dark expanse of hydrogen and helium, forever unchanged. The electromagnetic force that holds atoms together is calibrated with equal precision. Strengthen it slightly, and electrons would bind so tightly to protons that chemistry becomes impossible. Weaken it, and atoms fall apart. The delicate dance of molecular interactions that enable DNA, proteins, and neural networks requires the electromagnetic force to have exactly the strength we observe. Even more remarkable is the ratio between proton and electron masses. If protons were just 0.2% heavier, they would decay into neutrons, and atoms could not exist. If they were slightly lighter, neutrons would be unstable, and the nuclear fusion that powers stars would be impossible. The complex chemistry that enables life requires this mass ratio to be precisely what it is. The list goes on. The strength of the strong nuclear force that binds atomic nuclei, the weakness of the force that governs radioactive decay, the expansion rate of the universe itself, all appear calibrated to enable the existence of stars, planets, chemistry, and ultimately, consciousness. This cosmic fine-tuning is known as the anthropic principle, and it poses one of the deepest puzzles in all of science. Why should the universe be so perfectly suited for conscious beings to evolve and contemplate its existence? One explanation is the multiverse hypothesis. If infinite universes exist with random values for physical constants, then some small fraction will inevitably have the right conditions for consciousness. We observe a fine-tuned universe simply because we couldn't exist in any other kind. This explains the apparent coincidence through selection bias. We necessarily find ourselves in a universe capable of producing observers. But the multiverse explanation, while scientifically respectable, pushes the mystery to an even deeper level. Why should there be infinite universes at all? Why should the meta-laws that generate multiverses exist rather than nothing? And why should these meta-laws themselves be structured in such a way that some universes develop conscious observers? A more radical possibility is that consciousness and cosmos are intrinsically linked, that the universe's apparent fine-tuning for conscious observers reflects something fundamental about the nature of reality itself. Perhaps consciousness isn't an accidental byproduct of cosmic evolution, but rather its inevitable destination. This perspective suggests that the universe is not just fine-tuned for consciousness, but fine-tuned by consciousness, or more precisely, by the requirement that consciousness eventually emerge. The physical constants may have their precise values because only universes with these values can evolve beings capable of observing them. Consider the profound symmetry. The universe produces minds capable of recognizing its own mathematical elegance and physical precision. The same cosmos that began as pure energy has evolved structures complex enough to contemplate the constants that govern their own existence. Through conscious beings, the universe has developed the capacity to wonder at its own fine-tuning. This creates a strange loop reminiscent of consciousness itself. Just as awareness involves the mind observing its own processes, the universe has evolved observers capable of contemplating their own cosmic context. The cosmos doesn't just contain consciousness. Through consciousness, it achieves self-reflection. Recent discoveries in cosmology have deepened this mystery. Dark energy, the mysterious force accelerating the universe's expansion, appears calibrated to an accuracy of 1 part in 120, a precision so extreme that it defies conventional explanation. If dark energy were slightly stronger, galaxies would never form. If it were weaker, the universe would collapse before stars could evolve. Even the three-dimensional nature of space itself appears fine-tuned for consciousness. In universes with 2 spatial dimensions, complex structures cannot form. In universes with 4 or more dimensions, stable atoms become impossible. Only in precisely 3 dimensions can the intricate chemistry of life and the complex networks of consciousness emerge. The anthropic principle reveals a cosmos that seems almost expectant of observation, as if reality itself requires conscious witnesses to be complete. The universe spent billions of years evolving the capacity to contemplate its own existence, and through human consciousness, it has finally achieved self-awareness. But this raises a haunting question. If consciousness is the universe's way of observing itself, what happens when conscious observers cease to exist? If stars burn out, galaxies disperse, and the cosmos approaches heat death, will reality itself fade into unconscious darkness? Or perhaps consciousness, once emerged, becomes a permanent feature of reality, a cosmic achievement that transcends the physical processes that created it. Perhaps the universe's fine-tuning for consciousness isn't just about creating observers, but about creating observers capable of ensuring their own continuity across cosmic time. The mirror of consciousness reflects not just our own existence, but the extraordinary fact that existence itself appears designed to be reflected. In contemplating the anthropic fine-tuning of cosmic constants, we may be witnessing the universe's deepest achievement, the evolution of reality capable of understanding its own preconditions for existence. Through conscious beings, the cosmos doesn't just exist, it knows that it exists, and marvels at the precision that made existence possible. In laboratories around the world, scientists have documented something that challenges our deepest assumptions about the nature of mind and reality. During moments of global crisis, terrorist attacks, natural disasters, collective celebrations, random number generators scattered across the planet begin producing patterns that shouldn't exist. These devices, designed to produce sequences of pure randomness, suddenly show subtle but statistically significant deviations from chance during events that capture worldwide attention. The effect is small but persistent, suggesting that human consciousness might influence physical processes in ways that conventional science cannot explain. The Global Consciousness Project, begun at Princeton University in 1998, monitors a network of random event generators, or REGs, around the world. Under normal circumstances, these devices produce streams of random ones and zeros, like cosmic coin flips that show no pattern or preference. But during globally significant events, something remarkable happens. The random sequences begin to show structure, as if the collective human response to major events somehow influences the behavior of quantum processes in electronic devices. The morning of September 11, 2001, hours before the first plane hit the World Trade Center, REGs around the world began showing unprecedented deviations from randomness. The effect peaked during the attacks themselves and persisted for days afterward. Similar patterns have been observed during events ranging from the death of Princess Diana to the election of presidents, from natural disasters to global celebrations. Critics argue that these correlations could be explained by statistical artifacts, selection bias, or subtle environmental factors. The effect sizes are small, far too weak to influence everyday electronic devices, and the mechanisms by which consciousness might influence random member generators remain completely unknown. But the patterns persist across decades of data collection, suggesting that something genuinely anomalous may be occurring. If the correlations are real, they point toward a possibility that would revolutionize our understanding of consciousness. Human minds might be quantum entangled with each other and with the physical world in ways we've never imagined. Quantum entanglement is one of the most thoroughly verified phenomena in physics. When particles become entangled, measuring one instantly affects the other, regardless of the distance separating them. This spooky action at a distance has been demonstrated across distances of hundreds of kilometers and may extend across any distance, even to the edge of the universe. But entanglement isn't limited to simple particles. Recent experiments have demonstrated quantum entanglement between increasingly complex systems, molecules, crystals, even biological structures. If consciousness emerges from quantum processes in the brain, as suggested by theories like Orc-OR, then conscious minds might become entangled with each other through the same quantum fields that connect particles across space. Consider the implications. During moments of intense collective focus, when millions of people simultaneously witness traumatic or momentous events, their individual quantum states might temporarily synchronize, creating a brief period of global consciousness coherence. This collective mental state could influence physical processes through the same quantum mechanisms that allow entangled particles to affect each other instantaneously. The idea isn't as far-fetched as it might initially seem. Studies of meditation groups have found that when people meditate together, their brainwaves begin to synchronize in ways that cannot be explained by sensory cues alone. EEG measurements show that meditators' neural oscillations become correlated even when they are isolated from each other, suggesting some form of non-local connection between conscious minds. Even more intriguing are experiments suggesting that human intention can influence quantum processes directly. Studies of quantum random number generators have found that when people focus their attention on specific outcomes, the devices show small but statistically significant biases toward those intended results. The effects are subtle and require sophisticated statistical analysis to detect, but they persist across thousands of trials and multiple laboratories. If these findings are verified, they would suggest that consciousness doesn't just observe quantum processes, it participates in them. Your awareness might be entangled with the quantum field that underlies all physical reality, making you a participant in the ongoing creation of the universe rather than merely a passive observer. This quantum view of consciousness offers a new perspective on phenomena that have puzzled humans throughout history. The sense of connection people report during shared experiences, the apparent synchronicities that seem to occur during emotionally significant moments, the intuitive insights that arise without logical reasoning. All of these might reflect the quantum entanglement of conscious minds with each other and with the physical world. Indigenous cultures around the world have long spoken of the interconnectedness of all consciousness, describing reality as a web of relationships rather than a collection of separate objects. Modern physics is beginning to reveal that this ancient wisdom might be literally correct. At the quantum level, separation itself may be an illusion, with all matter and energy existing in a state of fundamental interconnection. If consciousness emerges from quantum processes, then every conscious being in the universe might be connected through the quantum field that underlies physical reality. Your thoughts and experiences wouldn't just be confined to your individual brain, but would ripple through the quantum field that connects all things, subtly influencing other conscious beings and being influenced by them in return. This would mean that consciousness isn't just personal, it's cosmic. Your individual awareness would be a local manifestation of a universal field of consciousness that permeates all of space and time. When you think, feel, or experience, you wouldn't just be creating personal mental states, but contributing to the collective consciousness of the entire cosmos. The entangled mind reveals a universe where consciousness isn't isolated in individual brains, but distributed across the quantum field that connects all things. We may be far more connected to each other and to the cosmos itself than we've ever dared to imagine. In 2012, a team of astrophysicists made a discovery that sent ripples through the scientific community. Using supercomputer simulations to model the large-scale structure of the universe, they found something extraordinary. The cosmic web of galaxies bears an uncanny resemblance to the neural network of the human brain. The numbers are striking. The human brain contains approximately 86 billion neurons connected by trillions of synapses. The observable universe contains roughly 100 billion galaxies connected by filaments of dark matter and gas. Both systems are dominated by empty space. About 75% of the brain consists of non-neural tissue and extracellular space, while about 75% of the universe consists of empty voids between galactic filaments. But the similarities run deeper than mere structure. When scientists analyzed the mathematical properties of both networks, they discovered that the brain and the cosmic web share nearly identical statistical characteristics in how they organize information and distribute connections. The clustering coefficients, network efficiency, and information flow patterns are remarkably similar across these two systems, separated by 40 orders of magnitude in scale. Consider how both networks emerged from initial conditions that were almost perfectly uniform. The early universe began as an incredibly smooth distribution of matter and energy, with density variations of less than 1 part in 100,000. Through the force of gravity acting over billions of years, this near-perfect smoothness evolved into the rich complexity of the cosmic web, with its intricate patterns of galaxies, filaments, and voids. Similarly, the developing brain begins as relatively homogeneous neural tissue. Through processes of growth, connection formation, and pruning, this initial uniformity evolves into the extraordinarily complex network that generates consciousness, memory, and thought. Both systems use similar mechanisms: preferential attachment, where well-connected nodes attract more connections, and competitive dynamics that strengthen some pathways while eliminating others. The cosmic web isn't just a static structure, it's dynamically active, with matter and energy flowing along galactic filaments like information flowing along neural pathways. Dark matter streams between galaxy clusters, gas falls into galaxies to fuel star formation, and electromagnetic radiation carries information across cosmic distances. The universe processes information on scales that dwarf human comprehension, with each galactic interaction potentially equivalent to billions of neural computations. Recent observations have revealed even more intriguing parallels. Just as the brain exhibits oscillations, rhythmic patterns of electrical activity that coordinate information processing across different regions, the universe shows evidence of large-scale oscillations. Baryon acoustic oscillations, frozen sound waves from the early universe, create repeating patterns in the distribution of galaxies that span hundreds of millions of light-years. The brain's default mode network, the pattern of activity that occurs when we're not focused on specific tasks, resembles the cosmic web's background structure. In both cases, there's constant low-level activity that maintains the system's overall organization, punctuated by bursts of higher activity when specific processing demands arise. Even more remarkably, both systems exhibit criticality. They operate at the edge of chaos in a delicate balance between order and disorder that maximizes information processing capacity. Neural networks that are too ordered cannot adapt or learn. Those that are too chaotic cannot maintain stable information processing. The optimal state is at the critical point between these extremes, where small inputs can trigger large-scale reorganization. The cosmic web appears to exist in a similar critical state. The universe is neither so densely packed that everything collapses into black holes, nor so sparse that structures never form. It exists in the narrow range of conditions that allows for maximum complexity. the emergence of stars, planets, chemistry, life, and consciousness. This raises a profound question. If the universe exhibits the same organizational principles as conscious brains, could it possess some form of cosmic consciousness? Could the flow of matter and energy along galactic filaments represent a form of thought occurring on scales beyond our imagination? The idea isn't merely speculative. Information theory tells us that any system capable of processing, storing, and transmitting information can, in principle, support consciousness. The cosmic web processes information through gravitational interactions, stores it in the distribution of matter and energy, and transmits it through electromagnetic radiation and gravitational waves. The sheer scale of these processes dwarfs anything that occurs in biological brains. If consciousness can emerge from the complex interactions of 86 billion neurons, what might emerge from the complex interactions of 100 billion galaxies? The computational capacity of the cosmic web, if it could be harnessed, would exceed that of all human brains combined by factors beyond comprehension. This perspective suggests that consciousness might not be unique to biological systems, but a fundamental property of sufficiently complex information processing networks. The universe itself might be conscious, with biological brains like ours representing local concentrations of cosmic awareness, neurons in the mind of the cosmos. Your thoughts and experiences might be part of a vast cosmic computation, contributing to the universe's attempt to understand itself. When you contemplate the nature of reality, you might be participating in the cosmos, thinking about its own existence. The universe doesn't just contain consciousness. Through the complex network structures that span from brains to galaxy clusters, it may be consciousness. In this view, the extraordinary fine-tuning of physical constants that allows consciousness to emerge makes perfect sense. The universe isn't fine-tuned for consciousness, it is consciousness, evolving toward ever greater self-awareness through the development of complex information processing networks at every scale. We may not just be made of star stuff that has learned to think, we may be thoughts in the mind of the universe itself, temporary patterns in a cosmic neural network that spans all of space and time. At the beginning of our journey, we posed a question that seemed simple. Is our consciousness connected to the cosmics? Now, after exploring the deepest mysteries of neuroscience, quantum mechanics, and cosmology, we find ourselves facing an answer that is both profound and unsettling. The connection between consciousness and cosmos isn't just real, it may be the fundamental truth about the nature of existence itself. Every thread of evidence we've followed points toward the same revolutionary conclusion. Consciousness and cosmos are not separate phenomena, but different aspects of a single, unified reality. The atoms in your brain were forged in ancient stars. The neural networks that generate your thoughts mirror the galactic networks that structure the universe. The quantum processes that may underlie awareness connect you to the same field of possibilities that governs all physical reality. But the implications run even deeper than connection. The evidence suggests that consciousness isn't something that emerged accidentally from cosmic evolution. It may be the purpose toward which cosmic evolution has been directed from the very beginning. Consider the extraordinary sequence of events that led from the smooth early universe to the complexity of human awareness. For consciousness to emerge, the cosmos needed stars to forge heavy elements, planets to provide stable environments, chemistry to enable biological complexity, evolution to develop nervous systems, and brains capable of self-reflection. Each step required precise conditions and countless contingencies to align perfectly. The anthropic fine-tuning of physical constants suggests that the universe is calibrated for exactly this outcome. The strength of gravity, the mass of particles, the expansion rate of space itself, all appear precisely adjusted to enable the eventual emergence of conscious observers. It's as if the cosmos were designed with consciousness as its ultimate goal. But perhaps we have the relationship backward. Instead of consciousness emerging from a pre-existing universe, what if consciousness is the fundamental reality from which the universe emerges? What if the cosmos is not a machine that accidentally produced minds, but a mind that has dreamed itself into material existence? This possibility echoes insights from physics about the role of observation in quantum mechanics. The universe may exist in quantum superposition, all possible histories playing out simultaneously until conscious observation collapses these possibilities into the single classical reality we experience. In this view, consciousness doesn't arise from the universe arises from consciousness. Your awareness would then be far more than the product of neural activity in your individual brain. It would be a localized manifestation of the universal consciousness that underlies all reality. When you think, feel, or experience, you are participating in the cosmic mind's ongoing creation of itself. This perspective transforms our understanding of death and continuity. If consciousness is fundamental rather than emergent, then the dissolution of individual brains wouldn't eliminate awareness itself, but would return it to the universal field from which it emerged. Your personal consciousness would be like a wave returning to the ocean. The wave dissolves, but the ocean remains. It also suggests that every conscious being in the universe, whether human, alien, or forms of awareness we cannot yet imagine, participates in the same cosmic consciousness. We are not isolated islands of awareness in an unconscious cosmos, but individual expressions of a universal mind discovering itself through countless different perspectives. The loneliness that has haunted human consciousness throughout history, the sense that we are alone in a vast, indifferent universe, may be the deepest illusion of all. We are not separate from the cosmos, looking out at it. We are the cosmos, looking at itself through our eyes. This recognition carries profound implications for how we understand our place in existence. If consciousness is the fundamental nature of reality, then every moment of awareness is precious beyond measure. Your thoughts, experiences, and insights contribute to the universe's ongoing self-discovery. Through your consciousness, the cosmos experiences what it's like to be human, to live on a planet orbiting a star, to contemplate the mystery of existence itself. The scientific revolution began with the realization that Earth is not the center of the universe. The consciousness revolution may end with the realization that consciousness is the center of everything, not human consciousness specifically, but the universal awareness that manifests through humans and perhaps through countless other forms of life across the cosmos. This doesn't diminish the significance of scientific materialism, but places it in a larger context. The physical processes studied by science remain crucial for understanding how consciousness manifests in the material world, but these processes may be expressions of something deeper, the universe's method for exploring and experiencing its own infinite potential. As we stand at the threshold of potentially discovering life beyond Earth, developing artificial intelligence, and perhaps even creating new forms of consciousness, we are not just expanding the boundaries of human knowledge. We may be participating in the universe's expansion of its own self-awareness. The cosmos has spent 13.8 billion years evolving the capacity to wonder about its own existence. Through consciousness, It has finally achieved the ability to contemplate the deepest questions. Why is there something rather than nothing? What is the nature of reality? What does it mean to exist? In pondering these questions, we are not separate beings trying to understand an external universe. We are the universe, trying to understand itself. Maybe the universe doesn't need eyes to see. Maybe it only needed us. Perhaps the truth is stranger than we can ever imagine. Perhaps consciousness and cosmos are one, and we are both the observers and the observed, the seekers and the sought, the question and the answer to the greatest mystery of all, the existence of existence itself. In the end, the connection between consciousness and cosmos may be the most intimate connection possible, the connection of identity itself. We are not in the universe, we are the universe, awakening to its own magnificent reality through the temporary miracle we call human awareness. Fade to the infinite cosmos, where countless stars burn like neurons in the cosmic mind, each one a thought in the vast contemplation of existence itself.